Hi, and welcome to the webinar. My name's Travis Lunkin. I'm Source Water Protection Coordinator with the City of Wilmington, Ohio. Today we'll talk about Clinton County, local watersheds, local streams, their water quality, and some things that can impact their water quality. What happens on the land really influences water quality in the streams, the lakes. We can measure water quality using biological, so we talked about that in the last presentation, how we use biological communities to put together an index that tells us about the quality of the water. Today we'll talk more about chemical parameters and the chemistry of the water. We use a multi-parameter probe when we're out in the streams. That really wouldn't have been possible without the help of Clinton Stream Keepers. They helped us to acquire that probe. So now we can go out in the field and measure conductivity, temperature, pH, dissolved oxygen, nitrate, and we can also estimate some other chemical properties of the water using that probe. So it's been very beneficial. First, we'll look at conductivity. I remember in probably middle school where we did the experiment where you have the light bulb, a battery, and a water bath. And when you stick the leads into the water bath, the light bulb does not light up until you add salt. And that salt increases the conductivity of that water. So that's kind of what this test does. Also, you can have dissolved inorganic compounds in the water. If we look at local streams, so we have 4 streams. 2 of them are in Cowan Creek, which is a larger stream, mostly draining off of fields and pretty rural area. The other ones, we have Indian Run and Lytle Creek. The Lytle Creek one, you see higher TDS. That's the estimated from conductivity value. You can see that that's higher. That's due to impervious surfaces. So you have parking lots, you have sidewalks, and anything that is applied to those washes off very easily into the creek. So that's pretty common when you get to urban areas or areas with more what they call impervious surfaces. If we look at this next slide, it shows it a little better even comparing all the sites. You can see Lytle Creek sticks out as being higher for that total dissolved solids. Temperature is very important because it regulates a lot of the biological and chemical processes that go on. It also greatly influences what can live in that body of water. For instance, trout require cooler streams, usually spring-fed, not quite as common in Ohio, but there are some areas that do have trout. One very unique and important quality of water is that it's actually less dense when it freezes. So as you get close to the freezing point, water becomes less dense and it floats to the top of the surface. So if you see a pond in the wintertime that's frozen over, underneath that ice is liquid water and it's insulated so everything else underneath can live, maybe moves a little slower, but yeah, that's very important. In summer months, having a tree canopy over a stream can really help keep it cooler. So that helps support fish species and just makes for a better quality stream. So having grasses and trees along the edges definitely is beneficial. If we look at temperature in the 4 streams in Upper Cowan Creek, what we see is seasonal variation, as you'd expect, and we see temperatures are pretty close between the streams. They're all fairly shallow, so whatever the air temperature is, the water can quickly get to that temperature. pH is a measure of acidity, and if you're on the higher end, it's basicity. The scale runs from 1 to 14, less than 7 being acidic, and more than 7 being more basic. Our streams are typically slightly higher, and that's because dissolved limestone and things that are dissolved in the water make it buffer, so it wants to stay at that range of about 7 to 8.5. So pH is important for us because it can tell you if there's a spill in the water, it can be an early warning for that. And it can also tell you if an algae bloom is taking off, because during an algae bloom, a lot of times the pH will start to go up. So talking about spills, in 2001, there was a train derailment that went into Cowan Creek. It was just above Cowan Lake State Park, 15,000 gallons of sodium hydroxide. They attempted to confine that spill, but they also closed the state park just out of precaution to make sure no one was injured, because sodium hydroxide will higher or raise the pH and can be unsafe, not only for aquatic life, but also for people. Luckily, that spill was downstream quite a ways from our water intake, so it did not impact drinking water in any way. If we look at pH of our tributaries of Cowan Creek and some of the streams, what we see is it's pretty consistent between all the sites, and that's thanks to that buffering capacity, keeping everything in that safe level. Dissolved oxygen. So dissolved oxygen influences the biological communities as well. It can also impact our water treatment. Higher DO levels are typically better. So flowing streams typically have higher DO than a lake. Cool flowing streams, even better. What we see in the wintertime, we'll see higher DO values. It influences what fish can live there, just like temperature. So certain species like carp can survive in low DO waters. Die-offs of algae blooms can also deplete the DO. Sometimes you'll hear about fish kills, and it's not necessarily a toxin, but it's often the dissolved oxygen in the water is removed, and you get that resulting fish kill. So here we see the dissolved oxygen levels in our streams. Really anything higher, like above 4, is pretty good. So at the current time when we are measuring, the DO values look good in all the streams and fairly consistent. We do see a seasonal variation in that in the wintertime, DO is a little higher. You get a little more oxygen that can stay in the water. Nutrients, we look at nutrients because they can be drivers of algae blooms and growth. So when we talk about nutrients, mostly we're talking about nitrogen, also N, and phosphorus, P. Nitrogen is very abundant, so the air is already about 60% nitrogen, but plants and algae typically can't harness that nitrogen very easily. So if you really want good growth, you have to have nitrate. Well, in the early 1900s, a chemist figured out how to get nitrate from the air. So he figured out a process to fix nitrogen. And really the chemical industry, that was a big start to it. One of the first things on a large scale. So that really helped with agricultural production. Phosphorus can be a little more limiting. So there's not quite as many, say, natural ways to get it. So we'll often apply phosphorus to get things to grow. And with algae, it's often, they say that it's phosphorus limited and that there's not a lot of phosphorus there. So any bit you put into the water can really help kick off these algae blooms. We do measure nitrate. It's kind of an estimated nitrate. And what we're seeing are lower levels in the summertime, higher levels when it's colder and in a spring. Part of the colder level or the colder higher levels could be because the plants aren't there to take up that nitrate. Therefore, it's in the stream and easy to be measured. What we see comparing streams is that the larger streams that drain more land, we're seeing higher nitrates, at least in our streams. Those nitrates often are said to come from point source or non-point source. So a non-point source could be a parking lot, a field, a yard, streets where it drains into a storm drain. As water flows into those, it picks up pollutants off of the land and carries them into streams. Non-point source pollutants typically are not regulated nearly as much as point sources. And it's difficult because you can't identify one specific spot. It's usually widespread. So they would be more difficult to bring under control. Point sources, on the other hand, you can identify an exact source, and those have been successfully regulated and controlled over the years. That's brought about some real water quality improvements, but upgrading, bringing about those improvements can sometimes be very costly. Thanks for attending this web presentation. I'll do a future video on algae blooms. We'll talk more about that. We can talk more about source water protection. So thanks again, and have a great day.